All right, this is the remainder of the notes from the 7A4 examples. So we're just finishing those up. We had the empirical rule. So this one is heights of men on a bell-shaped distribution. So normal curve with a mean of 172. So we'll put that in the middle. Standard deviation of 8. So we're going to add 8 and subtract 8 to move from left to right on our standard deviation listing. So this one would be 180. 188 and 196. If we subtract 8 from 172, we'd have 172 minus 8 is 164. Subtract 8 again. We get 156. Subtract 8 again. We get 148. So this is our spread out data values, 3 standard deviations below and above our mean. So now we want to know the percentage between the following values. So 148 to 196. So that's from here to here. Notice that's 3 standard deviations above and below the mean. That's the 99.7%. So that's directly from the empirical rule. From 156, which is here, to 188, which is here. Notice that's 2 standard deviation below to 2 standard deviations above. That's the 95%. And if I ask 164 to 180, that would be the 68%. So these are directly asking the in-between percentages for the empirical rule. All right, let's look at another one. It says, suppose a random sample of adult women has a sample mean height of 64.3 inches with a sample standard deviation of 2.4 inches. So we can go ahead and start putting those numbers along the bottom. 64.3 is the mean. If we add 2.4 to that, we get 66.7. We add 2.4 again, we get 69.1. We add 2.4 one more time for the third standard deviation above the mean, we get 71.5. So going back to 64.3, we subtract 2.4, we get 61.9 for the first one below. Subtract the 2.4 again, we get 59.5. And subtract 2.4 again, we get 57.1. So this, remember, direction we are subtracting the 2.4 standard deviation, and this direction we are adding it. So there is all of our labels at the bottom. So since heights distributions are generally symmetric and bell-shaped, we can apply the empirical rule where this is the mean and the S member is the standard deviation. So between what two heights are approximately 98% or 99.7% of the data? Okay, so that means we go 3 standard deviations above and below the mean. Remember, 2 standard deviations is 95%, 1 standard deviation above and below is 68. So 3 standard deviations above and below the mean is 99.7. So that ties to a height of 57.1 inches to 71.5 inches. Okay. Use empirical rule to determine the approximate percent of heights that lie between 59.5 and 69.1. So 59.5 is here, 69.1 is here. Notice that is 2 standard deviations exactly above and below the mean. So when you go from the same amount above and below, that's when you use the empirical rule big percentages. So this one's the 95%. So they're asking for the percentage. In the first one, they gave us the percent, asked us for the values. The second one, they told us the values and we found the percentage. All right, let's look at number 14. Consider again the inchworm population with a mean length of 1 and standard deviation of 0.15. So 1 and 0.5 is the standard deviation. So we're going to add that and subtract it to get our values down here. So it's easy to add it. That'd be 1.15, 1.30, and 1.45. If we subtract it, we get 0.85. One more time. If we subtract that 0.15 again, we get 0.7. And if we subtract that again, we get 0.55. Okay, so there's all my values at the bottom. What percent of inchworms are more than 2 standard deviations away from the mean? So this, let's make sure we understand what that means. Within or between means from the 2 to the 2. So the -2 to 2, this is within. Anything beyond that is away from the mean, okay? So we want to know what total percentage is in these tails down here. So if we think about, remember the empirical rule, it was 68% for the middle two. We learned how to split that up and divide it by 2 and get 34 and 34. Then we do the 95%, which is the 2 standard deviations minus this. That can give us the 13.5 on both of these. And so essentially you could just say, oh, that's 95%. So the opposite of that is 5%. We could get that really quickly. I already know that, but I'm going to show you that I can add up the pieces as well. 99.7% minus the 95 we already used, and then divided by 2 gives us that 2.35% we got in class. And 100 minus 99.7% was 0.3, divided by 2 is 0.15%. So I can get it a couple different ways. I could have realized, oh, they just want to give the opposite of this rule, which was 95%. So the opposite would have to add 5%. And then if you wanted to just add them, if you had all these, you would add the 0.15, 2.35, 2.35, and 0.15. Those are the ones on those tails, okay? What percent of inchworms are more than 2 standard deviations above the mean? That is only this group for part B. Okay, so just the above the mean. Below the mean is down here. Away could be either direction. So this one will just be the 2.35 plus the 0.15. It ends up being exactly half of the both directions. Okay. All right, and then our last one, it says returning to the sample of adult women with a sample mean height of 64.3. So we'll draw that out. And we had the standard deviation of 2.4. So I'm probably just going to go back up and grab those numbers instead of recalculating all those. So we had that up here. So it was, the second group was 61.9, 66.7. 61.9 and 66.7. And then we had 59.5 to 69.1. So 59.5 to 69.1. And this is, so I'm just recreating the graph we already did. 5, 7.1, 7, 1.5. So 5, 7.1, 7, 1.5. So remember, this was adding the 2.4 over and over again and subtracting it, okay? What range of heights would you expect 68% of your data to be in? So that's directly the empirical rule. So 68% goes from here to here. So the 68% range would be for people with heights of 61.9 inches to 66.7 inches. For part B, what range would you, oh no, sorry, this is still part A, I guess. I think this was supposed to be a part B. It just got deleted. Part B, what would you expect 99.7% of your data to be? So remember, that's 3 standard deviations above and below. So that's the 57.1 inch is to 71.5 inches. Okay. And then C, estimate the percentage of heights that are less than 61.9. So what is the percent for that? That's what we're asking for this last one. Okay, so if we're at 60, so we might need to put in our percentages again like we did before. So 34 and 34%. Remember, these are percentages. These were 13.5. You kind of memorize this after doing it a bunch. These ones ended up being 2.35 when we did our subtraction and then dividing by 2. And then these are 0.15. Now, something to note, both sides from the center should add up to 50% each. So 50% this way, 50% this way. But we're asking specifically from 61.9 and below. So we're adding those 3% columns. So 0.15 plus 2.35 plus 13.5, that ends up adding to 16%. All right, I hope this helped.